In this video, we are going to talk about the expansion of liquids. So, liquids need a container, okay? So, you need to keep any liquid in a container. When you supply heat to a liquid, so both the container and the liquid expands, and the liquid in it expands. So we have already discussed last time the change in volume of a container is equal to the the volume expansion coefficient times the volume at the colder temperature times the change in temperature. And now for solids, the volume expansion coefficient gamma is 3 times the linear expansion. So you have the change in volume of the container is equal to 3 times alpha times the volume at the colder temperature times the change in temperature. So this is the change in volume of the container. But activities show that liquids expand more than solids. Liquids expand more than solids. Consider a cylindrical object filled with some liquid. When you provide heat, in this case, if the liquid is not filled to the container, so we can think of the change in volume of the container, the change in volume of the container, the change in volume of the liquid, and the apparent. Now it's filled. There is some volume of liquid is overflow. There is overflow liquid. Now, how do we calculate the liquid's overflow? The idea is liquids expand more than solids. That's why we have some overflows. So the change in volume of the liquid is equal to, like the change in volume of the solids, we do gamma of the liquid times the change in volume of, the change in temperature and the volume at the colder temperature. Remember, there is no gamma of the liquid is equal to 3 times alpha, meaning there is no linear expansion coefficient for liquids. So the change in volume of a liquid cannot be written as 3 times alpha. Now you have a certain volume of a container. Then when you heat this object, so it has a volume. Before we heat, it was at T naught. So when you heat this object, you're gonna get that some change in volume. So if this is the total change in volume, let me divide the change in volume. I can divide the change in volume. So there is the change in volume. Initially it was maybe here. So due to the change in heat, when the temperature naught, the T naught is changed to some temperature T, so the volume is also it changes from the initial volume V to a final volume of V naught. Now it was here, meaning this thing is the volume. This is the volume of the liquid, the volume of the liquid at the colder, which is equal to the volume of the container, because it was filled with the liquid. Now after heating, there are two things happen. One is, so the container expands. There is what? The container also expands. So this is the whole change in volume of the liquid, and you can have some change in volume of the container. Solids expand smaller than liquids. So the thing above this expansion, this part is the volume, the change in volume apparent, or you can call it the volume overflow. Now how do we calculate the volume apparent? First, the change in volume of the container is 3 times alpha, the volume at the colder temperature, times the change in temperature. And the change in volume of the liquid is gamma of the liquid times the volume at the colder, which is the same as the solid, and which is the same as the change in temperature is also the same. Now this apparent change in volume, the change in volume apparent, or usually called the change in volume overflow. Okay, the volume overflow is equal to the change in volume of the liquid minus the change in volume of the container. So this is the volume apparent. Now this is equal to how much? The change in volume of the liquid is gamma times volume at the colder temperature. Volume at the colder temperature, V at the colder temperature, and the change in temperature, minus the change in volume of the container is 3 times alpha times the change in temperature, basically, which is the same as this liquid, and times the volume at the colder temperature. Now we have this one, the change in volume apparent is equal to the change in volume of the liquid minus the change in volume of the container, but the change in volume of the liquid is gamma times V at the colder times the change in temperature, minus this is the change in volume of the container is 3 times alpha times the volume at the colder times the change in temperature. Now you can take this volume colder and the change in temperature constant, because both the liquid and the solid has the same initial volume because it was filled. Okay, before you heat it, just you filled with the container. The whole container is the volume of the colder volume of the solid, and the colder volume of the container and the liquid are the same at the colder. You fill it and you heat it, and when you heat it, both the container and the liquid expands, but the liquid expands more than the container, so you have a certain apparent change in volume. Now the change in volume of the container, the change in volume apparent is equal to, so you can take the volume at the colder temperature times the change in temperature as common, then in the bracket you're left with this alpha and this one, so the gamma minus the volume coefficient of the liquid minus 3 times alpha. Now this is how you get the apparent change in volume or the volume overflow. But this gamma of the liquid, the volume coefficient of the liquid minus the volume coefficient of the solid, the container, usually denoted by the apparent, the change in volume, the apparent coefficient of volume expansion. So the change in volume apparent or overflow is equal to the V cold times the change in temperature times the gamma apparent, because the difference of these two is called the change in volume apparent. So the change in volume apparent is equal to the volume at the colder temperature, times the change in temperature into gamma coefficient of expansion for the liquid minus the coefficient of expansion of the container. So this is simply VC, change in temperature. Okay, now let us see the example. It says a cylindrical container made from iron, coefficient of linear expansion is 1.1 times 10 to the power of minus 5, is filled with water. At water, so volume expansion coefficient of water is given to full volume of 500 ml, and at 10 degrees Celsius you are supposed to calculate the change in volume, the change in volume of the cylinder or the container, the change in volume of the liquid, and the change in volume of apparent at 110 degrees Celsius. So let's do this. So we are given the VC is given, the VC is given, it is 500 ml, and the T cold is given, it is 10 degrees Celsius, and the T hot is given, it is 110 degrees Celsius, and alpha for iron is given, alpha for Fe is 1.1 times 10 to the power of minus 5, so gamma of iron is equal to 3 times alpha. So this is equal to 3 times 1.1 times 10 to the power of minus 5. So this is equal to 3.3 times 3.3 times 10 to the power of minus 5 k to the power of minus 1. Okay, this is the volume expansion coefficient of the various. Then the change in before the change in volume, another thing is given. So from those change in temperature, we have the temperature hotter and from temperature colder. So we have the change in temperature is T hot minus T cold, and this is T hot is how much? It is 110 minus 10. So the change in temperature is 100 degrees Celsius or Kelvin. All right, now the other thing given is the coefficient of volume expansion coefficient of the water is given. So it is 2.1 times 10 to the power of minus 4 k to the power of minus 1. So the three things are required. We are looking for the change in volume of the container, the change in volume of the liquid, the change in volume of the liquid, and the change in volume apparents are required. Okay, to calculate the change in volume of the container, we have already done in the previous video. The change in volume of the container is V colder the change in temperature times 3 times alpha. We have already calculated 3 times alpha. This is equal to 500 times 500 is centimeter, 500 centimeter ml or centimeter cube is the volume, times the change in temperature is 100, and the times the 3 times alpha is 3.3 times 10 to the power of minus 5. Now 5 times this and this is gonna be, so you can simply calculate this as, so this is equal to 5 times 10 to the power of 2 times 10 to the power of, so 5 times 10 to the power of 2 is 500 times 1 times 10 to the power of 2 is the 100, and times 3.3 times 10 to the power of minus 5. Now this is the same as so 5 times 1 times 3.3 times 10 to the power of 2 minus 5 is there, plus 2 again. So this is how it is. So this 5 plus 2 is from this 100, and another plus 2 is from 500. Minus 5 is already that given. Now this is equal to 1 times 5 is 5. 5 times this 3.3 can be, you can write that 5 as 10 over 2 times 3.3. all right, so times 10 to the power of minus 5 plus 2 is minus 1. So you can do this 33 10 times 3.3 is 33 over 2 times 10 to the power of minus 1. Then this 33 over 2 is 16.5 times 10 to the power of minus 1. So this is equal to 1.67 ml is the change in centimeter cube is better for solids actually. So this is centimeter cube, centimeter cube, or you can say ml. And similarly, you can do the change in volume of the liquid is equal to gamma of the liquid, the change in temperature of the liquid times the volume at the colder temperature. So liquids expand more than solids, so that is just seen in their coefficient. The gamma for solids in the order of 10 to the power of minus 5, but the gamma for liquids is in the order of 10 to the power of minus 4. That's why liquids expand more than solids. So we have 2.1 times 10 to the power of minus 4 for the gamma of water, times the change in temperature is 100, that is 1 times 10 to the power of 2, times the change in, the volume colder is 500, you can write 5 times 10 to the power of 2 again. So you can collect this 2.1 times the 1 times this 5 times 10 to the power of minus 4 plus 2 plus 2. Okay, so this is equal to 2.1 times 10 to the power of, now there is 5 here, so to the power of times 5 times 10 to the power of 0, So this is the same as, 5 times 2.2, you can write this 5 as, so this is 1 times this, so you can say simply 21 by 5, then this is 5, this is 10, so this is 10.5 centimeter cube or a milliliter. Okay, now the change in volume apparent, or the change in volume overflow, okay, is equal to the change in volume of the water minus the change in volume of the container. So this is equal to the change in volume of the water is how much? It is 10.5 centimeter cube minus 10.5 minus the change in volume of the container is 1.67. So this 10.5 minus 1.67 is 8.83 centimeter cube or milliliter. So this amount of liquid is overflow due to the change in temperature. Thank you for watching this video.